Hello everyone, I'm Brian Kopack from Formtek and welcome to Formtek Talks. In today's podcast, I'm joined by Kevin Enos and Charlie Burgess, and our discussion focuses on coil reels. More specifically, pull-off coil reels versus driven coil reels, and the things you may want to consider when you're making a decision about which is right for your operation, including things like where, why, when to use them. Thanks again for joining us. Welcome to Formtek Talks. My name is Brian Kopack. I'm with a company called Formtek, and I have two guests with me today, Mr. Kevin Enos from Formtek Maine and Mr. Charlie Burgess, also from Formtek. And today we're going to talk about coil reels, undriven versus driven, why you need them, where you want to use them, various instances. And I'm going to go ahead and let Kevin go ahead and start a little bit, talk a little bit about the coil reel journey that you've been on for 20 plus years. Tell us why you would want to have a driven coil reel versus an undriven coil reel.
Very well, thank you. The two types are driven and non-driven, benefits and detriments for each one based on the application. So starting with the basics of width, pretty much anything over a ½ inch wide up to 84 inches in width. And you also have the capability of paying off the top or the bottom. So your material comes over the top or comes from underneath. Then you also have your outside diameters, typically in the 60 to 72 range, 72 inch range is standard. ID range is also critical information for us as suppliers to have so we can size it properly to the material. And then as you get into the differences in paying off a motorized versus a non-payoff or a non-motorized unit. So if you've got a application where there is no straightener in between or nothing that's pulling off the material, that reel would have to be motorized in order to get your material from point A to point B. On an unmotorized version, you would have some form of powered pinch rolls, a straightener, a roll former, something in front of it that is actually going to pull the weight of that material off. So the material weight could be as low as a couple hundred pounds all the way up to 60,000 pounds. In addition, you'd also, as you start getting into different materials, want to consider things such as side guide rollers and keeper arms and things of that nature to safely handle the material, to keep it from clock springing, to keep it from expanding or exploding out to the side. So operator safety is certainly a big part of that consideration as well. The hold down arm is another major benefit, and with HSLA or high strength materials, you're starting to get more into various types of hold down arms or multiple hold down arms for a single coil. Typically they're an above the arm or above the reel hold down arm, but they have secondary hold down arms coming up off the ground from the back, or a hold up arm coming from the front if you're paying off from the bottom of that material. The other would be the types of coatings on those rolls. So if the material is surface critical, you're not going to damage, scratch, or mar that material. So that's the basic premise of the reels. And then I guess as far as how you would utilize those versus certain applications, if you've got an example, I can kind of...
Sure. If we often get asked by customers that, hey, my material is pre-painted material, and it's light gauge, say 20 gauge and under, and it's wide. So we're talking 20 inches, 12 to 24 inches wide. Many applications that I've seen, people will tend to have to utilize a driven uncoiler because they don't want to have a straightener pulling that material off because you could scratch the material. Is there a general guideline that you look at to say, yes, you're not going to have something pull the material off, but is there like, if you're below a certain gauge or a certain width, or is it just the fact that it's pre-painted and you don't want to damage the surface of the strip that guides your decision to have a driven or an undriven coil reel? Is there any general guidelines that you could recommend, or is it really case by case and you have to understand what's going on?
It's really, nowadays, it's really case by case, more so because you could say it's an 18 gauge material, but the type of material now, so again, it could be 18 gauge HSLA material, which is going to be a more difficult material to handle than it would be for a standard cold rolled or a mild steel material. Anything that's been coiled, you're going to have coil set in it. So a straightener is advantageous in having the ability to remove that coil set. If it's a soft material with no coil set in it, you could certainly put a straightener, a powered straightener in line that's going to pay off and not stress or stretch that material from one piece of equipment to another. But nowadays, the yield of the material is as much a dictating factor as the gauge is in determining whether or not a powered or a non-powered reel is going to provide the best utilization. Scratching is not so much an issue nowadays because of the different roll materials that can be utilized in the straightener to not induce marking. Ideally, you want a continuous operation on the straightener where you're not starting and stopping and introducing or potentially introducing witness marks into that material.
Excellent. Charlie, in your experience, and you've had not only roll forming experience, but other strip processing experience in your past life, was there any guidelines that you would always steer customers toward a driven or an undriven coil reel? Was there something else there? Because we've actually had some applications where we'll have a driven uncoiler and a straightener, just to double up and be super safe and not damage the material, or because it's very thin gauge and we don't want to stretch the material whatsoever. What's your experience with that?
Well, outside of roll forming in the steel mill industry, they're pretty much always driven because they're always trying to maintain tension zones within the line. So we never really encountered any kind of non-driven uncoiler.
Where it was pulling off,
it was always driven, and it was always pulling back. You were always trying to establish tension going into, say, a bridle, because all those lines have various tension zones from entry end to process section to exit end. But in the roll forming, with the non-driven, I always kind of looked at it as if there was a servo feeder, you had to go with driven because you didn't want to take a chance of slipping through the servo feeder rolls, pulling the inertia of the coil. But when I got into the non-driven, one of the things I kind of always was a little fuzzy on. So even when you say non-driven, there's still a drag device to keep the coil from overspinning, whether it's a pneumatic or a mechanical brake.
That's correct.
And how do you know whether you need to go with a pneumatic or a mechanical brake in a non-driven application?
Again, it tends to get more application specific. How you know the difference between the two, I think, is in part both in line speed and the coil weight in which you're trying to stop. Another, in this day and age, another convenience and something we're seeing more and more customers utilizing is what's called an automatically adjusting brake, where we're utilizing a laser sensor that's going to constantly measure the diameter of that coil, and will automatically adjust the brake according to that diameter of the coil. So wear and tear, maintenance by the operator or the maintenance personnel is greatly reduced, and the longevity of the equipment is enhanced as a result of that.
So when you dynamically adjust the tension using, I assume in most cases that's a pneumatic
yes.
brake, that's based on the difference between the OD and the ID, and when you're within a certain range, you really don't need to do compensation?
It's the difference between the overall OD, and as that OD changes, I believe it's 3 or 4 times through the course of that coil as it depletes. So as you have a fuller coil, you're going to need more brake pressure to stop that. As you get into a smaller coil, less brake pressure accordingly.
Okay.
And Kevin, tell us a little bit what's important if somebody's looking at a driven coil reel application. I would imagine you'd want to know how fast the line is paying off.
Yes,
that
certainly.
you have to keep up. Is there a rule of thumb for if I say I'm going to be running the roll former at 100 foot per minute, do you automatically say, okay, in my mind, I have to assume I got to hit speeds of 120 or 150 to keep up with the roll former? Yes. For feeding it. What's the rule of thumb there? 25%, 50%?
I believe it's around 25%, and Ideally, and especially as you get to the smaller, as the coil winds down or unwinds, so you have less of a coil on there, the reel's obviously turning faster, so you have to be faster than the rated line of speed. So that's a calculation that engineering performs in determining, again, a motor size in that case, to make sure that we are always running faster than the capability of the roll former or whatever piece of equipment may be in front of it.
I would imagine another scenario where you might decide driven or undriven would be safety. If somebody has to feed this coil into another piece of machinery and it's 20 or 40 inches wide, they would probably opt for, do they need a full motorized version? Or I do believe you have like a thread up version as well, which is kind of a form of a driven uncoiler, but it's not to top speeds, it's just for helping.
That's correct. The distance isn't necessarily a factor of determining whether it's driven or non. There is a thread up mode on a non-driven straightener that allows you to both unwind the material to feed to the next successive piece of equipment. There's also the ability inherent in that is to rewind equipment back. So if you don't fully utilize material, you can rewind that coil using that same jog function for rewinding it. The determination whether or not to use a powered reel or a non-powered reel isn't affected by the overall distance of an application. You can use thread tables and various other means to get the material from point A to point B. And again, having the jog function on a non-motorized reel is what allows you to then feed, again, that next piece of equipment in line.
What's the latest in technology to, when you're looking at a driven coil reel, to assess the speed that the material is being pulled off? It used to be dancer arms.
Correct.
Do you still use dancer arms, or is there newer technology out there?
A newer technology, primarily lasers today, although there are applications. Soft lead for batteries would be an example where a loop arm is still utilized, but almost everything has gone to a laser. Photo eyes is another. So if you have a pit, for example, photo eyes on either side of that pit wall to recognize where the material is located. But the premise is the same for whether it's photo eye or the dancer arm or the laser. It's measuring the high and the low of that material. You never want it touching the floor where it can drag contaminants into a press or a roll forming application and the tooling, or you're going to have I lost my train of thought, I'm sorry.
Well, if you're talking about damaging the strip or tight lining.
The voltage basically is what you're utilizing there, so 0 to 10 volts. So all three of those methods utilize the same methodology as far as making those adjustments. So the lower you get into the pit or into the loop, the slower you would go, even if you're just slowly creeping along that material. As that material starts to come up in the loop, in order to prevent it from tight lining, the reel then has to run faster to put more slack into the loop itself.
Yeah, but wouldn't the photo eyes, the laser actually, like you said, works on voltage, so it's dynamically adjusting continually as the loop goes up and down.
In small increments.
In small increments. My experience with photo eyes is you have a series of photo eyes. So you have one at the bottom, you have one at the top, and one in the middle. So you don't really have the control,
the
right?
finite
control that you do with laser?
That is correct. The responsiveness with a laser is far greater, yes.
Is there any drawbacks to using a laser, like a reflection on the material? Or do you have to, is there any special things you can't use the laser on? You mentioned lead. Is the reason for that is because it's too soft, or is it the fact that it has a reflective property and you can't match that with the laser?
With lead, it's the opposite. It's porous, so getting the feedback from the laser is more challenging.
You can't get enough reflection.
Correct. I'm not aware of any issues with a laser and having ability with shiny metal materials, painted materials, embossed materials. It doesn't seem to be impacted by any of those. So I would say overall, no, there aren't many negative aspects. In fact, there's usually more positive associated with it than negative. So going back to the sonic age of loop control, that could be affected by outside noise. So if you have a welding machine that's close to a line, that noise, electrical noise, could affect the sonic controlled unit. Cold air So if you have equipment that's by an open door in the wintertime, it will sense that cold, dense air where a laser is impervious to that. So there's actually more benefits to the laser than there is with most of the other older type of technologies that are out there.
I've seen a similar issue with photoelectric with light. If you have a lot of windows in the plant reflecting off and causing errors with that also.
Oh, I was not aware of that.
In some of the steel mill applications, they had highly lit bays, and they had reflectivity, which would throw off the photoelectric.
I'll be done.
I know there's when we touched on safety a little bit ago with for threading options that you can use for operators. I know our group tends to use a specific option that Formtek Main offers, where it's called a safety brake in case there's a power outage. Are you seeing a lot of your customers starting to utilize that feature? Because I would think that would almost be mandated, that if you lose power, that either air pressure or power, the brake cinches up the uncoiler, essentially.
The short answer to your question is yes, we are seeing that more. More customers are becoming safety oriented. It comes down to a matter of cost. If you're an operation that uses a line 24/7, that's certainly easier to justify. If you're a smaller shop that runs one shift and you have more personnel that are available to tend to it, as we go forward, more and more customers are requesting automation. So by having those functions that are done automatically by job number or whatever means is becoming the more preferred method.
Anything else that you'd like to add versus driven or undriven?
Not as necessarily as it pertains to driven or non-driven, but I would add one of the variations on the reels is the utilization of a single versus a double reel.
Oh, that's an excellent point.
So you have a single mandrel that you're either going to load or unload a coil off of. You're going to run out that coil. If not, you're going to be rewinding it, rebanding it, removing it. The benefit of a double end coil, you have an online and an offline side to that coil. As a result of that, you can be loading or unloading the offline side of that coil while you're running or threading up the online side of that coil. So it shortens the amount of downtime and the throughput should therefore be increased as a result of the increase in uptime. So if you're a location that uses a lot of partial coils, does a lot of changeovers, certainly a double reel is very advantageous for that.
And all the features that we've talked about can be applied to the double coil reel world as well. You can have safety brakes, thread up drives,
Absolutely.
Motorized payoff. All of that can be applied.
That's correct.
Yeah, I agree. We, a lot of our roll forming systems, customers are starting to add more and more, or upgrade more and more to the double coil reel. So that's definitely a good feature. Charlie, what about you? What have you seen? Are there certain features you're always starting to add?
Well, the safety feature for sure, with the brake. But beyond that, customers are kind of up and down on whether they want single or double reel. With the high production lines, obviously the high speed lines, they're going with double because that's really what they're after is low downtime. But there's still quite a few single reel applications. One thing I did see, which I hadn't seen in a long time, was requests for closed face mandrels, which, basically you've got contact with the ID of the coil all the way around the circumference, as opposed to some of your more typical ones where it's like three arms. You've got, contact.
Or three mandrel.
Three expanding mandrels, but there's a gap between those segments. And I'm not sure what's exactly driving that, but it is quite a bit of an upcharge when you go with the closed face.
There's a couple of different ways. We have on smaller systems, usually 6,000 pounds and under, it's a 4-arm system. And what tends to happen as you deplete the coil itself wants to egg shape from the ID out. And obviously thinner gauge materials can be adversely affected by that. So then you get into, on the larger coils, the 3-drum mandrel, like you said, it does allow space. And in some cases, that space is utilized for loading. So using a C-hook to load a coil, as an example, you have to have a gap in between those mandrel shoes to get that hook in there and out of there, or a sling would be another one. To go to a full radius mandrel, the main intent there is, as you said, is to not deform the ID of that coil, and what we call a pumpkin tooth style, which is what allows those mandrel shoes to overlap one to another and give you more of a 360-degree protection against that, is the fact that you're not going to deform those thinner gauge materials and take the last maybe 2 inches of a coil and deform it to the point where it becomes non-usable or scrap material.
Yeah. Does that limit the expansion range? Closed face as opposed to the 3-segment?
It can. As a general rule, no, there's enough gap in there to allow a traditional 4 to 6 inch expansion and contraction range, but it certainly can if you've got, it's usually going to be customer driven. If they get the material on cores, for example, there's a lot less variation on what that ID range is going to be versus if it were going to be on a non-cored coil.
Mm-hmm.
All right. On behalf of Kevin and Charlie, my name is Brian Kopack. I'd like to thank you for tuning in to this edition of Formtek Talks, and we look forward to seeing you on the next episode. So hopefully our discussion was helpful to you. As you can see, there's a lot that impacts the decision of which type of coil reel to use, and of course, each situation has its own unique specifications and operational constraints. But that's why we're here to help you as you make these evaluations. So please don't hesitate to reach out for a consultation. The best place to do so is through our website at formtekgroup.com, and there's absolutely no obligation. We'd love to understand what you're looking to do and see how we can help you achieve your objectives. For now, thanks again for listening. On behalf of Kevin Enos and Charlie Burgess, I'm Brian Kopack. Join us again for the next episode of Formtek Talks.